Today, I'm Paras, Night on leetcode. Today we are going to start a daily challenge series in which we will daily solve the leetcode daily challenge together. Uh, you can watch this series if you're stuck somewhere and find needing a hint or just needing a complete solution. I will live solve the problems. So let's start from today's daily challenge. Verifying an alien dictionary. It's an easy problem. An alien dictionary where we in dictionary problems we just have to use a map and something like that. It's obvious. In an alien language, surprisingly, they also use English lowercase alphabet letters. First, let's first understand the following statement. In an alien language, surprisingly, they also use English lowercase letters, but possibly in different order. The order of alphabet is somewhat some permutation of lowercase letters. Okay, so we are given an order. A permutation. Permutation means a unique. Permutation means just like from 1 to n, there are only 1 to n numbers and they are in a unique combination. I mean, from 1 to, if we have a permutation of n numbers, there cannot be 4 greater than a number n to 1, n plus 1, and there cannot be a number smaller than 1. So we are given a permutation of lowercase letters, in which means that from A to Z we are given a permutation in order. So the general order we study in English is A, B, C, D, E, F, G, lexicographically uh, ascending. That order is reshuffled and permuted, and we are given that order. And we also given some letters that are arranged according to the new order which the author of the problem has given to us, and we have to tell, are these words arranged according to the order? Okay, if they are arranged all of them, then return true, and even if one of them is wrong, we have to return the false. Okay, so in alien language, if and only if the given words are sorted lexicographically in alien language. So approach of the problem we can get is, the first thing we will have to do is to map the new order to the digits, the all digits. Just like from we want we map A to 1, B to 2, but in this we will map H to 1, L to 2, A to 3, and Z to 26. Just like we can see that. And after that, I can see that we will check one by one. Just like if hello is smaller than lead code, is in according to this, and then if there is a third one, it is smaller than the second one. We don't have to check first with third, because if first is smaller than second, it will always be smaller than the third. So that's how we will approach the problem. One by one we will check, and if it returns false, if it returns false, then the answer is false. If all all are true, then answer is true. We will first dry run and then we will code, and in we will dry run we will test different cases. Okay, so let's pick up this example. First example, not the first one, the third, second one. Or let me create myself. So these are our words. They are our words. Words are oh, these are our words. Okay, and this is the order. This is the order, and we will create a hash map. We will create a hash map of 26 letters, something like this. There from zero, I mean W will be there. For one, O will be there. For I'm not like this. Uh, not like this. For W will be zero. O will be one. R will be two, and L will be three. So that we can just look in the hash map and check that O is less than L or greater than. because the older lexicographical order is changed, and according to the new one we will map O to its value. So 1 is less than 3, so O is less than LL. That's how we will approach the problem. We will just define a map and we will check one by one. The problem is solved. Okay, so let's try run. Let's try run. Just like the world and world. W and W is same, so we'll move forward. O and O is also same. Then we will pointer. We will maintain a I here, I, J, and if they're same, I will move right side. I also move right side in both of them, and we will move up to D. Okay, D, and here it is L. So we'll check in our new map. R is on position. D is on position 5, and L is on position 4. So L is less than D. But in this we are given L is in this we are not given according to that. So this is false. Okay. So mainly we have to just compare two words. जब तक वो इक्वल है, जब तक आगे दोनों के पॉइंटर को आई को आगे बढ़ाते रहेंगे, और जब वो इक्वल नहीं आएंगे जो वर्ड्स हम दोनों की स्ट्रिंग्स कंपेयर करें हम एक एक करके, when the words won't be equal, then we will check in the map, and if it satisfies, then we will return true, and if it's not, then we will return false. Okay. So if all of them are satisfying the previous conditions I mentioned, then the answer is true, else the answer is false. So let's code this, and between the code I will explain you again. So first we have to create a hash map. Okay, I will quickly code it so we can understand between the. So we have created the hash map. This hash map will point the order to the its value, so that we can quickly compare, as I previously mentioned. Okay, point I is equal to 0. Y, sorry. We have the version of your order. Okay, and in hash map we are going to in hash map we are going to mention order I is equal to I. So this is our hash map, and now we will traverse over the words. Okay, and we will check for adjacent ones. If, if even one of them fails the condition, the answer is false. And if all of them satisfies, the answer is true. So we will check the neighboring ones, because if 1 and 2 are satisfying and then 2 and 3 are satisfying, then 1 and 3 are automatically satisfying, because 1 is less than 2 and 2 is less than 3. 1 will always be less than 3. That we study in math. That's the thing. Okay. If this is false, then our answer is false. Okay. Otherwise, our answer is true. We have to check for all. So if all of them are true, then we will return true. Okay. Now we have to check them, and we have to check them according to the our new hash index, new lexicographical order. So we will enter this obviously here, string s1, string s2, and our map, our hash map, beautiful hash map. Okay, and let's start from zero index, and n will be s1 dot size, s2 dot size. We have to take care of several conditions while comparing two strings. I will mention them while coding. Not let's start mention them. If s1I is equal to s2I, then we will move right side, because they are equal, so we can determine which one is smaller and which one is greater just by because they are equal. Then so that they are not equal, we will move pointer and s1I, s2I. I plus plus. We will keep moving forward. And if now string 1 is finished, you understand? If now string 1 is finished, but string 2 is not finished, or maybe if string 2 is finished, string 1 is finished, but string 2 is not finished, okay, then our answer will be true. Just like if string 1 finishes and string 2 remains, then string 1 obviously will be smaller than string 2, okay. And if I is equal to n, and and uh, just like I'll explain you, u, v, u, u, v, w, x, हमारा आई यहाँ पे आ गया है दोनों में, ये खत्म हो गया लेकिन ये बचा है, समझ गए? तो फर्क नहीं पड़ता, इट विल ऑलवेज स्मॉलर, ये कंडीशन मैं मेंशन करूंगा, आई एम गोइंग टू मेंशन दिस, इफ आई इज ओके, if I is equal to n and m is greater than n, if n is greater than n then our answer will be true, okay. And other approach can be कि I बचा हुआ है लेकिन मतलब n n n के n बचा हुआ है अभी, m से बड़ा हो गया वो, मतलब n is greater than n, इस केस में फॉल्स रिटर्न करेगा। और अगर दोनों ही खत्म हो गए तो ट्रू ही आएगा, मतलब तुम ऐसे ही कर सकते हो, ठीक है। अब देखते हैं, अभी इक्वल नहीं है तो हम हैश में फाइल यूज करेंगे। इफ एम पी इज, ये हम हैश में से चेक कर रहे हैं, अगर ये इससे बड़ा है, ठीक है, तो हमारा आंसर फॉल्स आएगा, हमारा आंसर ट्रू आएगा। So let's try and run this. Okay, first test case is running. I have covered all test cases in my assumptions. Let's submit this. Done. So this is our lead code daily challenge for today.